Well, hi there, and welcome to Lesson 1-1, where we're going to be looking at variables and expressions. Our goal today is to be able to create an algebraic expression using numbers and symbols. In math, these words tell us to do something. They represent a mathematical symbol. These symbols allow us to shorten up phrases, kind of like what you do with texting. When you text a friend, you probably don't type out every single word. You use shortcuts. Well, mathematicians do the same thing. They use symbols for each one of these operations as a short way of writing something. So let's talk about these 4 operations. What are some symbols and words that mean the same thing? Let's start with add. What's a symbol that means to add? Yeah, the only one that we have is this sign right here. That's it. That's what we have. That means add. Well, what other words might you see that tell you to add 2 numbers together? The very mathematical word is sum. I want you to circle that in your notes. We need to know that that means to add 2 numbers together. But what other words mean to add 2 numbers? Yep, you've got it. Plus. We could say combine. Yep, we could increase. If I took 5 and increased it by 3, I'd get 8. Deposit. If I make a deposit into my bank account, I am adding money in there. Of course, I could say more than. I could also say put together. You might see the word total. Lots of words. And maybe you have some more that you can think of that you would like to add to your notes. All right, let's look at the next word here. Subtract. What mathematical symbol tells us to subtract 2 numbers together? Yep, that's the only one. So what are some words that we might see that would tell us to subtract? Well, the very mathematical word is difference. Do you remember that? I want you to circle that in your notes so that it sticks out to you. But what other words tell us to find the difference between 2 numbers? What other words tell us to subtract? Yep, minus, decrease, take away, fewer than, maybe less than. We could say withdraw. If I withdraw money out of my bank account, it means to subtract or take away. Maybe you can think of some more. Go ahead and add them. Now let's come on down here to multiply. There are lots of symbols that mean to multiply. Well, for instance, we have the times sign, but we've kind of moved away from that when we started learning algebra because it looks like the variable x. We also have a dot. A dot represents multiply. So I could show that I'm going to take 5 times 3 or 5 times 3. I could use the star, the asterisk. That tells me to multiply. I could put one of the numbers in parentheses. I could put both of the numbers in parentheses. I could put brackets around the 3. Now, if I have a variable and a number, I could just stick them together with no symbol. It's an invisible symbol, and that means multiply also. So you got to recognize all of these tell us the same thing, to multiply 2 numbers together. All right, so let's think about words. What other words mean to multiply? The very mathematical word that you're going to see is product. Product. The product of 2 numbers tells us to multiply. Find the product of 5 and 3. Well, that would be 15. Times. Hopefully you remember the word of. Of means to multiply. Half of 10. That means half times 10, which is 5. If I asked you what twice your age is, you'd multiply your age by 2. If I asked you to double your age, you'd multiply your age by 2. If I asked you to triple your age, you'd multiply your age by 3. Those are all words that tell you to multiply. So we got lots of different ways we can say multiply. All right, if you can think of more, go ahead and write them down. Divide. What symbol tells us to divide? Well, typically you're used to seeing this, right? This little divide sign. And even in elementary school, you might have seen this, right? But when we're talking about division here in algebra, we're going to be using the fraction bar. So we might write 15 divided by 3, or we could write 15 divided by 3, whether you like to use the fraction bar horizontally or slash. I don't care, but we want to be sure we're using the fraction bar there when we're talking about division. The mathematical word for divide is quotient. If I ask you to find the quotient between two numbers, that tells you to divide. But what else would mean divide? Well, maybe out of. I could say 3 out of 15. That means 3 divided by 15. I could say split or cut evenly, right? I could say per. All words that tell us to divide. All right, the ones that you have circled are going to be the ones that you're going to see a lot, and you've got to know what those mean. So the sum, difference, product, and quotient, be sure they're circled in your notes. All right, and there we have some words and symbols that tell us the operations we perform in math. Okay, here we have some very tricky words that sometimes is hard to figure out. How do I take these words and write them mathematically with symbols and numbers and letters? These are sometimes called the turnaround words because you have to kind of switch the order. And so we'll talk about these. Let's first look at less than. And actually, if we think less than, fewer than, subtracted from, and taken from are all talking about one symbol. And it's the subtraction symbol, right? So anytime you see subtraction, you really got to be careful because the order could be flipped. So let's talk about this first one. And you want to put these examples in your notes. Less than. What if I have 5 less than n? Can you write this one down? 5 less than n. Well, think about what if this number was your age? What if I said, what is 5 less than your age? Well, wouldn't you take your age and subtract 5? Wouldn't you take the number that's your age and take away 5 in order to find 5 less than your age? Yeah, absolutely. Now, do you notice what happened here? The 5 and the n had to switch places for us to write this. That's why it's a turnaround. Okay, let's try another one. What if I said fewer than? So let's do the same example here. What if I said 3 fewer than the number that represents your age? 3 fewer than n. Is this 3 minus n? It's not. Think about your age. 3 fewer than your age. Your age minus 3. Wouldn't that be 3 fewer than your age? I mean, if you were 10, 3 fewer than 10 would be 10 minus 3. You'd be 7 years old, right? So again, this is going to switch. I'd have n minus 3. 3 fewer than the number n. Okay, this next one, subtracted from. Well, let's say that I have 7 subtracted from a number. Would that be 7 minus n? What if it's 7 subtracted from your age? If I said to take 7 subtracted from your age, wouldn't you take the number that's your age and then minus 7 after it? Absolutely. Again, even though I see the 7 before the n, I have to switch them around when I write the expression. And the last one here, the words taken from. What if I have 2 taken from n? Okay? Think of this as 2 taken from the number that's your age. What's 2 taken from your age? Well, that would be your age minus 2. So again, the 2 and the n switch. Now notice in both of these examples, you see the word than, less than, fewer than. So that's kind of easy to remember. Those are going to be turnaround. We got to be really careful with the subtracted from and the taken from. The from and the than, those are kind of key words. Okay? So these are our turnaround words. Now our next job is to take these algebraic expressions that we see written as a phrase and to simplify them by using algebraic symbols and numbers. So think of this as kind of like texting. I wouldn't have to text by typing all of this. I could shorten it up using numbers and symbols and have it mean the same thing. Okay, mathematicians want to shorten things up just like you want to do that when you're texting a friend. All right, so we got 3 more than twice a number x. And if you'd like to pause the video and then check your answer by fast forwarding, you can do that too. So if you want to try these on your own and then check them, you can. So 3 more than twice a number x. We've got some keywords in here. More than, we have 3 more than, and then we have twice a number x. So I'm going to do these in different colors. So 3 more than, I could write that as 3 plus, because plus means more than. And now if I look at twice a number x would be multiplying x by 2, 2x. Now, the commutative property tells me I could have these two switched around also, and it's still correct. Notice that with multiplication, I did not use a dot. I did not use parentheses. As simple as I can get it, I can just have an invisible operation where I stick them together. Okay? Let's try number 2. Okay, on number 2, I've got 9 less than, and then I have the quotient of 6 and a number n. So I got a couple things going on. Now less than, I know that that's a turnaround word. So I'm actually going to save that for last. I'm going to go right over here to this part, quotient. Now this word quotient right here, I know that that means to divide. When I see the word sum, product, quotient, or difference, those are connecting words. Just like you learned back in 6th grade, the connecting word is and. So I look to see where it says and that's where my symbol goes. So the quotient of 6 and a number n. My symbol goes right here where the word and is. 6 divided by the number n. Now, do you remember what I said about division? We were going to use a fraction bar. So I'm going to write this as 6 divided by n. The quotient of 6 and a number n. Okay, now let's go back over here to this part. 9 less than. I want 9 less than that. So think if I wanted 9 less than my age, I would subtract 9 after my age. I put it at the back. So here I have 9 less than the quotient of a number in 6. All right, here I see that I have the sum of a number C and 7. And then I also have the product of 4 and the sum of a number C and 7. Lots of stuff going on here. Maybe you want to pause the video and give this a try and see if you're right. Let's go to here. Sum of a number C and 7. Sum means to add. Well, this is also one of those mathematical words, sum, product, difference, quotient. And I know that the connecting word right here, and, tells me where to put the symbol. The sum of C and 7 is C plus 7. Now, it tells me over here I want the product of 4 and this. Again, product is that word, that fancy word for multiply, that mathematical word. Again, I can also use the word and here as the connecting word. And I know that I'm going to be multiplying by 4, right? There's a problem here. Because this tells me the product of 4 and all of this. I want to multiply 4 by all of this. And right now, using order of operations, I would just multiply 4 times C. So what am I going to need over here to be sure that this stays together? You're right, parentheses. I'm going to put parentheses around it. You may have learned in 6th grade that when you see that word sum, that whatever you see with it has to put parentheses around it. I'm not sure if you remember that or not. But now we have 4, and we're multiplying it by the entire quantity C plus 7. And this would tell me to get the C plus 7 first. On this last part of your notes, we're going to be looking at reviewing some vocabulary. Here we have an expression, and it tells us we have 3 multiplied by x, and we have that added to 2. So we could say the sum of 3x and 2. But what I want you to do is take a look at each one of these parts, A through E, read the definition, and see if you can match it to the word over here. So you'll put the letter C on whatever line that it would match up with. Maybe you want to pause the video and give that a try and see how much you can remember. All right, well, we have this entire expression right here. This whole thing is an expression. And so an expression is a phrase consisting of numbers, variables, and some operation symbols. So that would mean that letter E would be algebraic expression. Now this algebraic expression has a 3x and a 2. And each of these that's separated by the addition sign here, these are each called terms. So we've got a term is a part of an expression that's separated by an operation sign. So term, that's going to be A right here. And if you remember from last year, you can simplify by combining like terms. Like if this had a 2x, we could add them together, right? Those are terms. We know that a letter that represents a number is a variable. And the variable that's being used up here is this x. So a letter that represents a number is a variable, so D is the variable, and that's the x in this example. Now the last two left are called the coefficient and the constant. Think of that prefix co, like co-teacher, co-worker. Co-teachers work together, they teach together. Co-workers, they work together. Co means with or to come together. So a coefficient is a number that's attached to or attached with the variable. So the coefficient in this expression would be the number 3. That's our coefficient. It comes with the variable, which would then leave the last one as our constant. A constant is a number that stands by itself. And so this right here, this number 2, that would be our constant, plus 2. So just reviewing some vocabulary terms when it comes to expressions. All right, thank you for joining me for this lesson. Have a great day.